Hello everyone, welcome to the channel. So in next video of sorting algorithm and techniques, we will move forward towards merge sort. So merge sort is basically a type of sort where we use the technique of divide and conquer. So merge sort is one of the most popular sorting algorithm, and that is based on the principle of divide and conquer algorithm. So the principle says that we divide the array or the data that is available in our algorithm, and then we divide them into small elements. Okay, then after dividing those elements, we use our technique conquer to conquer all these elements into the sorted one. So what exactly happens here? So first we divide the complete array into a small portion of elements. We divide it till the end we get a single element. Okay, and at last, after dividing it, we then use the conquer technique to conquer it, to sort it elements, and we compare it with each other, the elements, and see if the elements are in the sorted form. So in the conquer technique, we after getting those single elements, after completing this step one of divide, we then use the conquer to conquer those elements by adding up all those elements with the sorting technique. So at the end we get a sorted array or sorted list through merge sort. So let's see the dry run of this algorithm to have a better understanding. Okay, so let's start doing the dry run. So we were having an array. So I will be having an array with elements 6, 3, 9, 5, 2, and 8. Okay, so we were having an array, and it's an unsorted array, and through merge sort we are going to sort this array. So as discussed, in merge sort we are going to use the divide and conquer technique. Okay, so first we are going to divide this array into the smaller elements. So this array will be divided. So to divide the array, the formula we used actually is starting index plus ending index divided by 2, and we pick the center. Okay, so I have two parts here, so I will be dividing this into the two parts, 6, 3, and 9. Okay, so this will be my first step, where given array will be given array will be divided. We break this given array into the two parts, and we divide it till we get the smallest elements, and we then sort this array. So 639 is one part, 5, 2, 8 is second part. Then I further divide this 6, 3, 9, 5, 2, 8. Further I divide this to 6, 3, 9. Okay, this was 5. No, 3, 2, and 8. Okay, so now we have divided our complete array into the smaller parts, into the smaller elements, till the last element, or I would say uh, till the first till the element got only my number would be 1. Okay, so after getting these single elements, we have completed the step 1. The step 1 is divide, as we will now move towards conquer, the step 2 in this divide and conquer technique, and we conquer the elements by adding all these elements with the sorting technique. Okay, so we sort it like in 6 and 3, smaller one would be 3, so 3 and 6. Then I compare it with 9, then 9 is the smaller one. Then here 2, 5, 8. Then here 3, 6. Okay, in this I have 2 as smaller, 3 then 5, 6, 8, 9. So this will be my array after conquer. But what exactly we do in conquer is basically we compare the two halves of the array. Okay, so first half I have is 3, 6 and 9, this. Okay, and second half was this half. Okay, so I compare this element with this element. Okay, and I see if my 3 is smaller than 2. Okay, if it is, then I will place 3 here, but it's not, so I will place 2 here. Okay, then I'll compare 3 with 5. If my 5 is lesser than 3, then I'll place 5, otherwise I'll place 3. Then I'll compare 6 with 5. 5 is smaller, I'll place 5. Then 6 with 8, I'll place 6. Then 9 with 8, I'll place 8. And then at last I'll put 9 here. So what exactly we do here, let's again see. So first I do divide in step 1. Step 1, I'm going to divide this, and in step 2 I'm going to conquer this. So in conquer, let me explain you what exactly we are going to do. Okay, so now I've taken one more array. Okay, so now I've taken one more array, and what I'm going to do is this array is, you see, we have divided this, we have divided. Okay, now we have again divided this. Okay, so here we are doing divide. Okay, but you, if you see here, from this step onwards we do the comparing. Okay, we basically compare these elements. So after getting these two elements, not the elements, after getting these two array, this one and this one, we consider this as starting index, and we consider this as ending index. We consider this as starting, this as ending index, and we compare this element with this element. If 6 is, less than 10, then I'll place 6 in my array. Then I'll compare 5 with 10, then I'll place 5 here. Then I'll compare 12 with 10, then I'll place 10 here. Then I'll compare 12 with 9, then I'll place 9. Then I'll compare 10, 12 with 1, then I'll place 1, and at the end I'll place 12. So in this way we basically compare, just ignore these variables, because here we can see that smaller one is at the end. So first we usually divide, then after dividing it all the elements, we do basically this step we do in the form of recursion. So after doing this, at the end we left out with this. So between these two I'm going to compare. So this will be my SI equal to EI, starting index and ending index, and this will be my SI equal to EI. So I'm going to compare between these two, or either of between these two. So if let's suppose I compare this, so it will be my 5 and 6. Then I compare between these two, 5 and, so 5 is less than 12, so I place 5. 6 is less than 12, so I place 6, and the left out I place it directly 12. Then in between these two I got this, and after here I'm going to compare SI is this, EI is this, ending in this SI EI. So I'm going to compare 5 with 1, so 1 is smaller than 5 with 9, 5 is smaller than 6 with 9, 6 is smaller. Then 12 with 9, 9 is smaller. Then 12 with 10, 10 is smaller. So now you see only 12 is left, nowhere I'm going to compare. So we place these element as it is. Let's suppose if I have 13 or if I have 18 up here, then I will be directly placing those those elements 3, 12, 13 and 18 directly here, because I have already compared these elements. Okay, so we can see that 12, 13 and 18, these three elements, I don't have any other elements to compare up with the second array. So I'll directly place this 12, 13 and 18 up here in the sorted array. And in the merge sort, we utilized a another array, and in this array I will be copying my sorted one. Okay, so I'll consider this as the sorted array. Okay, and after this sorting is complete, I'm going to copy this sorted array into the original one. So in this way basically we solve or sort the array using the merge sort. Now talking about the time complexity, so we do here two things. Firstly basically we do the divide, and then we do the conquer. So this divide basically takes big O of n, and this conquer takes log n, and after combining these two it makes log n of log n, big O of n log n time complexity. And as you know we are utilizing another array. So space complexity, as in the previous sorting techniques, would not be same up here. So merge, in the merge sort, space complexity would be there because I'm utilizing another array here in the merge sort, as I'm going to copy the sorted array into the original array. So space complexity would be big O of n. Okay, now let's move forward and see the program for the merge sort in Java. Okay, so now we will start writing the program. First I have created the main method. Here I will be defining my array. Same array I'll define that I have picked for dry run. Okay, and now I will be creating my method divide. Here I will be passing array starting index and ending index. Starting index would be 0 and ending index would be n. Okay, now in the divide method we have to write the divide logic. So I'll just take this at n minus 1 because I have taken the starting index as 0. I will be starting from 0. Now in the divide method, first we need to pick the middle or center element. So for that usually we pick the mid element as si plus ei divide by 2. But in the case where we have starting and ending index is quite large, and adding up those two may comes out of range for the integer type. So for that we are going to utilize using this formula. So starting index plus bracket on ending index minus si divided by 2. Okay, so we usually are going to use this approach as when there is the size of arrays approx equal, then this condition might pass. But the above one or the previous one that I told you about, that might fail because integer type has 32 k something of limit, 2 raised to the power something limit. Okay, so that might fail. So we are going to consider this approach to calculate the middle element. And one more thing, we are going to add condition if in any case starting index is greater than or equal to the ending index, then I will return. Okay, now I'm going to recursively call my divide. So here I will be passing array, and for starting index I'm going to pass si, and ending index is mid because I have divided into the two parts. And for the second one I'm going to pass mid plus 1 and ending index. Okay, so this divide will call recursively till we get the single element. Next I'm going to write my conquer method. Okay, so in this conquer method what I will be doing, I will be sorting the array. Okay, but I also need to call this from here. So in this conquer method I will be passing array starting index, mid and ending index, and here I will be declaring its parameters si, mid and ending index. Okay, so as I told you, we are going to utilize one more array, and using this array we are going to sort our array, sort our initial array. As with this array we are going to have all those elements in the form of conquer, and while conquering those elements we are going to place all those elements in the merged array, and after end of this sorting we are going to copy the merged array into the original one. So the size of merged array would be ending index minus starting index plus 1. So this will be the size of my array. Now I'm going to take two index 1. My index 1 would be the starting index, and index 2 I'm considering mid plus 1. So why I have considered this, let's take the example up here. Okay, let me just change the color. Okay, so why I have taken this si would be 0 because starting index is the 0, and mid plus 1. So let's suppose mid is 2 plus 1 equal to 3. So my first half of array is like 0, 1 and 2, and second half would be mid plus 1, 2 plus 1 equal to 3, 4 and 5. Okay, so that is why I'm going to compare now this 0 with 3. In any case 0 is smaller, then I place 0 up in the merged array. Then I'll compare 1 with 3. 3 is smaller than 3 here. 1 with 4. So that is why we are going to take two indexes, because we have two divided array up here. Okay, now I'm also going to take one more element, one more variable. This variable x equal to 0 will be the index of the merged array, as it will be tracking up the element for the merged array. Now I'm going to use the while loop, and here I'm going to put my condition: if my index 1 less than equal to mid and my index 2 less than equal to ending index. Okay, then again, if my array of index 1 less than array of index 2. Okay, so if my this 0 is less than 3, then I will insert in merged array. So initially my merged array is 0, so I'll explain you this condition. Okay, then I'll just add index plus plus. Okay, so what this condition means, this condition means that initially my merged array here is 0. Okay, so in the merged array of 0th location I will place my array of index 1, but after inserting this I have to do the increment. So I need to again write this x plus plus and index plus plus. So to shorten this, what I have done, merged array x plus plus and equal to array index plus plus. Similarly, if any case this case is not true, then what I will be doing, I will be inserting this in the merged array x plus plus and array index 2 plus plus. Okay, so if my index 1 or if my initial starting element is not less than the second array, then I will do the reverse condition. Okay, and after doing this, what we are going to do, so after doing this, if my all elements are there, but sometimes the left out elements are there, so for that what we are going to do, so for those left out element we are going to add those elements simply in our merged array. Okay, so comparison logic above is done. Now the above array will work till we are comparing the both divided arrays, and in case suppose we completed the one array, then those left out element we can add directly. So for that we are writing this while loop. So here again I'm checking if my index 1 is less than mid, then I'll simply no need, then I'll simply add in the merged array. Okay, else if this is not true, if my index 2 is left out in any case and it is less than, then I will add in the merged array. Okay, index 2. Okay, so this is the case, and now after doing this we are going to copy the merged array into the original one. So for that I'm going to run a loop int I equal to 0, j equal to si, and if my I less than merged array dot length, then I plus plus and j plus plus. Okay, now I'm going to copy this. So I'm going to copy this in my original array. Okay, now let's run this program and see the result. Okay, okay, so I haven't printed the array. Okay, so we see our array is sorted, but let me explain you what exactly we are doing in these steps. Okay, so I'm going to run this in debug mode. Now you see I'm going to divide this first. So my initial is 0 and 5 and mid is 2. So this will be dividing 0 to 2. Okay, 0, 1 and 2, 6, 3, 9 it's going to divide. So first it will divide this. It has divided. Now my 0 is the starting one, ending is 2 and mid is 1. Again it will divide this. Now starting is 0, ending is 1. Now again it goes to the again divide method. So now I see my arrays there. Now my si would be mid plus 1. So mid is 0, 1 and ending would be 1. Now again it's going to conquer. So at conquer I'm going to pass this 0, 1 and mid would be 0. So here I come. So you see I have elements as 0 is my starting index, mid is 0 and ending in 1. So in 6, 3 I'm going to do comparison. So after doing comparison I'm going to left out with 3 comma 6. Okay, now
I've done the comparison. Now I'm just going to place the left out elements, and I'm going to copy it in the original one. Now you see 3 6 is there. Now it comes out of the loop again, it going to divide. Now I have mid as 1, so this one is 1. EI is 2, 0, 1 and 2. Now again I'm going to conquer this. So this is already sorted 3 6 and 9, so nothing will be happening up here. Now again it will just check those conditions, it will come out of the loop. Now again I'm going to check. Now my SI would be 3 and EI would be 5. Again I'm going to divide this 3 4. Now again I'm going to divide and again use conquer, and then again going to conquer. So what exactly is happening up here? Like initially I have told you, we are going to use the divide and conquer. So an array of 6. Okay, so first we have divided this as 3 6 and 9 first part, then 5 2 and 8. It was initially as 3 6 and 9, not 3 6 9. So first we considered these two, we sorted out these two, then we considered these two. So I compared this with this and this with this. Then after getting this as sorted 3 6 and 9, we have 5 2 at 8, second array. Okay, second you can say array or second part. So here we compare 5 with 2, so 2 5 we have left. Then after getting this, we are going to compare this with 8. 2 is smaller than 8, comes here. 5 is smaller than 8, comes here. Now 8 it left out, so left out we placed in the array. Now we are have this 2 3 6 9 1 2 5 8. Now we are going to compare these two, and after comparing these two we will compare with each other. Si would be this, ei would be this, si would be this, ei would be this is going to compare with this, 2 is going to place here. Now 3 with 5 3, 6 with 5 5, 6 with 8 6, 9 with 8 8, 9 is left out, so 9 will be placed. So in this way we basically do the merge sort, and we do the divide and conquer technique. We use this technique and basically we split all these elements into the smaller one till the single element is left out, and then we use the conquer technique to sort this element. So this divide portion basically takes big O of n, and that conquer part takes big O of log n. That makes the time complexity big O of log n. So this is what we have in merge sort. So I think that's it basically for today. If you have any doubt or questions related to merge sort, do let me know and I would be happy to help. Thank you.